Hello, today we're going to solve a problem involving a buoyant force. Let's read the question together. A container is filled halfway with the water. Which of the plots below correctly represents the buoyant force as a function of the submerged volume of the object as we start adding alcohol into the container? So we're given a container that's filled with water halfway, and there is an object that's floating in it. Now we start adding alcohol into it, and we have to figure out how buoyant force will change as a function of the submerged volume. So what happens if we start adding alcohol into a water? The density of the water is 1 gram per centimeter cube. The density of alcohol is less. It's 0.9. It's roughly 0.9 grams per centimeter cube. As we add alcohol, the overall density here drops. Now the question is whether it's going to affect or not affect the buoyant force. Well, to address this, let's draw all the forces that are present here. First of all, let's draw the object, right? So you have object, you have a weight pulling it down, and you have a buoyant force pushing it up. So what's buoyant force and weight? Well, buoyant force is given by the following equation, which is density of the liquid times gravitational acceleration times the submerged volume. So this fraction of the volume contributes to the buoyant force, right? And the weight is just the mass of the object times the gravitational acceleration. If object is not moving up into the air or not sinking into the container, then these forces should be equal, right? So buoyant force is balanced by the weight. Okay, so as we add alcohol, what's going to happen? The density of the liquid is going to decrease, as we mentioned earlier. Density of the liquid decreases, more and more volume will be submerged. But does the buoyant force changes? No. Let's draw what happens when you add. Well, let's consider this case, right? So when we added alcohol, so this is a new level for the liquid, object is sank a bit more, so the submerged volume increased. But does this equation change? The answer is no, because object is still floating. It's not flying out into the air, or it's not sinking to the bottom of the dish. So this is still valid. So even though the volume which is submerged under the liquid increased, the buoyant force did not increase. So which of these graphs represents this situation? Well, here, let's look at A. Does A represent this? So if we increase the submerged volume, the buoyant force has to increase. Well, that's not the case, right? So the only correct answer where the buoyant force stays the same. So none of these are correct. So the correct answer is E. So that's our answer. And that's a solution for this problem. Thank you.